Hello, everyone, and welcome to the Safety Artisan. I'm Simon Danucci, and I've been a safety engineer and consultant for over 20 years now. So, when I decided to start my own business, I was wondering what I was going to call it. And I looked around at various names, some of which were already taken, and I came up with the name The Safety Artisan for the business and the website safetyartisan.com if you want to take a look. And I came up with that name because I liked the word artisan and what it meant and the connotations. So first of all, artisan means a skilled person who does something by hand. And it can also refer to a thing that is, specially handmade, usually with high quality materials. So I like the sound of that. And I think it's appropriate, even in this modern age where I've worked on, huge projects, multi-billion-dollar projects that lasted for years and involved thousands of people. Because even on a big project, we're still relying on individuals being competent to do a job and to know how to do it, um, and to have that skill and that awareness and that understanding. So that artisanship that appealed to me. I thought that's good. And another thing was that there's this connotation of somebody working alone at home, maybe a sort of a cottage industry type setup that used to exist before the Industrial Revolution. Oh, I should say before the first Industrial Revolution. Now, whichever Industrial Revolution we're currently in at the moment, I don't know. But we've gone back to a world where, thanks to the internet, you can sit at home and do work. And in fact, thanks to, the recent global pandemic, more and more of us have been sat at home doing work, working remotely over the internet. And I, as an individual, can reach hundreds, thousands, or even millions of people over the internet with my teaching and with my knowledge and experience. So, the internet has really enabled a return to those kind of cottage industry ideals where individual people can do something of high quality and find a market for what they're doing, regardless of big brand, big business, etc., etc. So we can, you and I can communicate one to one or one to many, and you can communicate with me, and we can learn together and share together what we want to do. Now, if that sounds good to you, if that sounds something that you're interested in, then please check out the videos and other learning products at safetyartisan.com. And you'll also find me, Simon Danucci, on udemy.com. So if you want to see what I do on a third-party platform, and then that's there too. Okay, well, thanks very much. And I look forward to seeing you again soon. Cheers.
Well, that's enough of that. And welcome. Hello, everyone. Welcome to today's webinar on hazard tracking systems and hazard logs and risk registers. So before we're just seeing some people coming on board, it's good to see some of you. Hello there. So whether you signed up with Eventbrite or whether you're here on YouTube or Facebook or LinkedIn or X, formerly Twitter, you're all very welcome. So first of all, can I just check that you can hear me okay? Can anybody just give me a thumbs up or a oh, thank you very much. James, is that? Thank you. So good, you can hear me. I once did a webinar where I had my microphone switched off for half the time and I was really annoyed with myself. Anyway, so we've got an awful lot of content tonight. So what we're going to go through, I did a video some time ago, 35-minute full-length video on the sort of the basics of hazard logs and risk registers, and I've done a highlights video of that recorded, which we'll have later. So that's just 12 minutes for you to look at. So when we start that, if you know the basics, go and have a cup of tea or a coffee or whatever where you are. And so that'll set the scene for hazard logs and hazard tracking systems. And then I've got a double session on the more advanced stuff. There's so much in that presentation, I've split it in two. But we'll go through that and then we'll have a Q&A session. Although I just wanted to say, great, thank you for those who've replied in text that you can hear. Thank you. So do keep any questions or points, put them in the chat, please. And then whether I will answer them straight away or when we get round to the Q&A session, do put them in the chat. I've already put some links in the chat, but we'll talk about that later. So we'll have the Q&A session. I'm going to do a later session, which will probably go on the Safety Engineering Academy website about putting hazard logs into spreadsheets. We'll talk about that in passing, but I'm not going to get into that very much. And then, just to look forward to our next section on causal analysis, which will be in about a month's time. So we've got a lot to go through tonight, so let's get on with it. What I'm going to do is I'm just going to upload. Let me just get rid of that. I'm just going to upload this highlights video. And as I said, it's 12 minutes. So where are we? So that's just coming up. And I will let my alter ego take over the younger, slightly better looking version of me. So hope you enjoy this brief video. 12 months and then I'll be back live and we'll get on to the more advanced material. Okay, here we go.
Hi everyone and welcome to the Safety Artisan. I'm Simon and today we're going to be talking about hazard logs and hazard tracking systems. So topics for this session right now, commonly asked questions. So what is a hazard log? What is it? And what do we do with it? The key elements of a hazard log, what needs to be in it to make it work, hazard log management, what we need to do, and what about software hazard log tools? Now, we'll be looking at that in much more detail in sessions 2 and 3, but we'll just go over the basics today. And when I say hazard log, you can substitute hazard tracking system at all times. So that neatly brings us on to what is a hazard log. But the definition is really useful in that it tells you what a hazard log is, but also it defines a hazard log in terms of what it does. So it says a hazard log or hazard tracking system is a continually updated record of the hazards, accident sequences, and accidents associated with the system. I always think of Captain's log in Star Trek, which, the idea that it's just like a ship's log, it's a recording of everything that's happened. Well, you can do that. So we're managing a system, whatever it might be. It might be a physical system, a vehicle. It might be an enterprise, a business. It might be a piece of software. It might be an IT system. So it could be any one of those things. And the hazard tracking system enables us to manage all the information that we need to look at risks associated with that system. And it's worth saying that normally we use hazard logs for safety, whereby we're worried about harm to people. So you can use a hazard log or a risk register for in any application. We might be talking about financial loss, damage to reputation, to equipment, harm to the environment, all of these things. Well, it's structured, and we'll talk about structure in a moment. So structure implies we've got lots of pieces of information, but they are linked together into a coherent structure. So it's a structured means of storing and referencing safety risk evaluations and other information relating to an equipment or system. We've done some risk assessment, okay, which is a structured series of risk analyses in order to look at the total picture of risk. And finally, as it says, it's the principal means of tracking the status of all the hazards, decisions, and actions to reduce risk. But it's all about tracking the status. And we saw in the middle of the definition about storing and referencing risk evaluations. Okay, so we're probably referencing out to other documents, to other artifacts that record and analyze the risk in detail. But the hazard log is our key to finding all of those things. So we have references in there, and we can track the current status of where we think all these risks and hazards are. You know, how much risk is there associated with our system? And as you can see, it's defined by what it does, and what it does are also the benefits of using a hazard log. So first of all, you remember just now we talked about what goes in a hazard log, hazard risks, and everything to do with the accident sequence or accident sequences associated with the system. So typically what we have in a hazard log is we have a bunch of hazards. Now, each hazard may have multiple causes. There might be hardware failure, software failure, environmental issues that could give rise to a hazard, might be erroneous human activity. All sorts of causes can lead to the one hazard. And also, one hazard can lead to a number of different consequences. Don't worry about, I'm not recommending bow tie analysis, but it's a great way to represent and explain an accident sequence. And as we can see, hazards linked to accidents and hazards linked to causes, but causes do not directly link to accidents because you've always got to go via a hazard. Those are the documents. So maybe we've got a database full of documents, or maybe we've got physical documents, or a mixture of the two. The hazard log references to those documents. So basically, you've got your argument here that you've managed all of the hazards appropriately. Let's say you've reduced the risk of your hazards down to an acceptable level, and that's all documented and justified in the somewhere else, but you've got links to it. So not all, in fact, the minority of hazard logs in my experience go that far, but it's an ideal to think of. It requires a lot of discipline to link all the documents in and have that level of configuration control, but it can be done. So we've talked about hazard log management in the sense of what a hazard log allows us to manage and what it allows us to do, more sort of the benefits. So an individual or a team of people maybe. So if we're managing a complex system, things will be happening in the real world, which we need to track. So maybe we've had incidents, maybe we've had near misses, maybe unfortunately we've had an accident. So an incident might be that a hazard has occurred, but it hasn't led to an accident. So we're looking at that and going, well, actually, the probability is worse or better than what we thought it would be. And we need to update the hazard log and keep track of that. The reason that we're doing this is the hazard log is there to support decisions made by people in authority. So, and those people in authority, they need an accurate picture of the risk to say, well, what is the real level of risk? You know, we said we would go ahead and use this system because we thought the risk was down here. Maybe now we realize there's more risk in what we're doing than we thought. Can I accept that, or do I have to reduce it? And so the hazard log helps us to rank risks and say, these are the most important risks. These are the biggest risks that we should be paying the most attention to, because we should be reducing risk. We should be continuously monitoring to say, is the system running acceptably or at an acceptable level of risk? And the hazard log helps support those decisions by ranking risks amongst other things. So at the micro level, we need to make sure that the data in the hazard log, but we've also got to be aware that if we don't manage the hazard log properly, we could end up with something that just doesn't work as a hazard log anymore. And a big part of that is the fifth one, which is, or both micro and macro quality control, is configuration control. This is the kind of view that you get from a purpose-built hazard log tool. So it's built upon a database, and then typically up the top here, we've got some basic information: title, description, who put it in, what project phase are we at, etc. And what's the likelihood, for example. So we've got links to accidents, controls, causes, references, and history in this database. And we can link all of those things together to get that structure, to get a picture. Now, in the second session of these 3 lessons, I'm going to be talking about commercial tools that are all based on database. And then in the third session, I'm going to be talking about how you implement some of that in a spreadsheet. But if you observe certain rules, you can have a spreadsheet that does some of what a relational database will do. And if you are careful to observe the discipline of setting up the spreadsheet correctly and not corrupting it, then you will get most of the functionality of the database. And I can hear the purists howling at me as I say that, but in the real world, most people use a spreadsheet. This diagram is based upon the ISO 31000, which is a very, very common unified risk standard. And then the hazard log enables good communication and consultation, because certainly the commercial hazard log tools, or if you make a database or make a hazard log with a database, you can use the database functionality to generate bespoke reports for different stakeholders. Risk assessment is an activity or a series of activities, but they do go together very well. Now, another very commonly asked question is, what's the difference between a hazard log and a risk register? So if we go back to, I talked about a hazard log supports this risk process. However, differences are typically for a hazard log, we are using a hazard log to track safety impact. I think the ISO 31000 standard of a risk is the effect of uncertainty on objectives. So whatever you're doing, if you've got a project, you want to deliver something specific at a specific time to a specific cost, well, okay, you can look at the risks to those objectives. Your risk register can look at all the risks that might trip up your enterprise and stop it working. So we need a risk register or a hazard log to do all of that. So those are the key differences with hazard logs and risk registers. In reality, they're really quite similar, and some risk registers incorporate the idea of a risk event. So if you've got a risk register that supports that concept, it's almost identical to a hazard log. And there's more to come. As I said before, in the second session, we're going to look at the features and benefits of commercial hazard log tools. Now, and actually, that brings us neatly on to the third session, which would be, how do we make a proper hazard log in a spreadsheet? Because we can set up tabs in a spreadsheet where each table is a list of entities, be it causes, hazards, controls, references, whatever it might be. Each one of those is an independent table, and then they link to each other properly using the primary key in each table. This was Hazard Logs and Hazard Tracking Systems. I'm Simon, and thank you for watching The Safety Artisan.
Okay. Well, thank you, former Simon. Hope you enjoyed that. So that was a highlights of session 1, and I'm now going to do session 2 as promised, and session 3 is still to come. So let me just check. You can still hear me, I hope. Give us a thumbs up if you can, please. Thank you. And nothing worse than banging on and no one can hear you. So I'm going to share the screen now, and here we go. Okay, so what we're going to talk about now, and as I said, we've got a double session on full function hazard logs, what we can do with a relational database running our hazard log or hazard tracking system or risk register. So the point of what we're doing is so that we can understand the different entities in a hazard log. Not every hazard log will have all the entities, but it's good to understand what you might have in there. To understand how those different things, those different tables relate, to understand the data associated with each entity and why we're recording it, the benefits, to be able to select hazard log features to meet your needs, because not every user needs every feature. Okay. The log is there to support, the tool is there to support the process that we're following. Okay. And the process is there to support our business objectives or our legal obligations, whatever they might be. And there's a whole bunch of other functions that a database can give us, the benefits it can give us, that I'm not going to go through in detail because we'd be here for hours. Okay, but I've got a list of those towards the end, which I hope you'll find thought-provoking. Now I'm going to be using an example of a hazard log tool, which is an old hazard log called Cassandra. But the point is not to sell Cassandra, because I'm not doing that, or to say this is what a particular tool can do. It's an illustration only. It's a lot easier to show you an example than it is to talk about things in the abstract. So that's what we're going to do. And in fact, I think unless you're doing work for the UK Ministry of Defence, you can't actually get access to Cassandra. So I'm not selling or plugging the tool because you can't actually get it. So what we will cover in these sessions, the key elements, as I've said, and primarily accident, causal control and hazard data. We'll talk about the other functions and how, again, the tool supports the process. And you've already seen that slide, so we won't spend too long on that. So worth saying, as I said in the previous session, the underlying hazard model that we've got that supports all of what we're talking about today is the idea where we've got multiple causes leading to one hazard, which may lead to multiple consequences. And not all of those consequences will be harmful. Okay, a lot of them might be quite benign. And we look at that accident sequence, okay, that sequence of events moving from left to right, and we might try and interrupt that with controls, okay, to stop the accident sequence and prevent harm occurring. But that's the model that we're assuming when we're doing all of this, and I think it's worth mentioning that. You saw this in the previous session, a good reminder that a hazard log, really done properly, is a relational database where we've got lots of entities which have many to many relationships. So a cause may lead to more than one hazard, a hazard may lead to more than one accident, controls may be applied to multiple different things, and then we've got references, and maybe we've got some link out to another database full of documentation, maybe our safety case, the totality of evidence that we have. So that's what that illustration is showing in a slightly humorous way. And on the right hand side, from bottom to top, you can see we've got the accident sequence in a slightly different form. Okay, so that's setting the scene. Let's talk about what we might or what we want to see in a hazard log. So I'm going to start with looking at a screenshot of Cassandra and this is the accident screen, and most of the screens look very similar. And we're going to talk about each one of these blue boxes. So on the left hand side, we've got our overview. We've got a sort of a tree representation, a bit like a file explorer, of what we've got in the database. We've got at the top, we've got the leading particulars of the accident. Okay, so title, description, the status, where it is in its life cycle, because all the entities in the database are on a life cycle, might be draft or approved or retired, whatever it might be. Who came up with it, the project phase, and the accident owner. Okay, and you know these fields are not set in stone. You can choose which fields you want for your project, usually when you're setting up a database like this. And then we've got accident probability and severity in the middle box. And what is the risk class? Well, it's unknown at the moment because we haven't set it. And we can have an initial and a post control status in the middle there. And then at the bottom, we've got the other entities that the accident might link to. So we can link our accident to multiple hazards, multiple controls, multiple references, and there will be a history. Okay, we'll talk about these things in more detail. But there's an overview of what the kind of data you might capture relating to accidents. So, as I've said, on the leading particulars, and we have this on all screens basically. So we've got title, description, what's the status of the entity, who came up with it in the first place, who put it in the database, what is the accident to? Is it an accident to people, to equipment, to the environment, or whatever else you want it to be? You can these things are usually user definable. What phase of the project are we talking about? Are we in design, manufacture, in service, maintenance, retirement? What is it, and who owns it? Okay. And as I say, not all of these things are compulsory. We've got the probability and severity, both initial, the uncontrolled status, and the post-control status. Now, a quick word on this. This pre and post control only makes sense if we're talking about something new that we're developing, where we come up with an idea and go, okay, we could just have this thing. What's the risk of this thing with no specific safety controls? Oh, it's too high. Well, we need to add some. Now, these days, a lot of the stuff we do is off the shelf, or we're integrating things that already exist, or modifying something that already exists. So very often the thing that we've got has already been in service. It already has controls. So having a sort of an initial and post control status doesn't always make sense. Okay, you've got to look at this depending on what your needs are, what's going on in your project. It may be that you just say, okay, we've got the initial status is maybe our system with the existing controls, which we've identified and put in the hazard log, and then we simply add our post control, further controls maybe. So that's how we maybe get our post control status, and that will do us. Oh, excuse me a sec. I've just got some cramp in my leg, which is most unpleasant. Right, let's carry on. So, as I said, we have links to other entities whereby we're going to create these accidents, and then we're going to link them to other things that we've created in the database already, whether it be hazards controls, etc. And then we will see the benefit of those links in just a moment. And that's really, these linkages are really what sets our relational database apart, how we relate all these things together. It's extremely powerful. So in the overview tab on the left, I said it's like a file structure almost. We've got a list here of all of the accidents, hazards, causes, and controls, and we can have other entities in there as well. But not only is it just a list, okay, you see the numbers in brackets. So that is the number. So if we look at the top, we've got against accidents, we've got 1000. So in this case, we have 4 stages of life cycle for each entity. And we're going to, so we can track how many accidents that we've got at different stages of the life cycle. Okay. And look at everything in the database, get an overview of what we've got. And that grouping, and again, the user definable grouping. So we might have groups of hazards or causes. We might relate them to the system or product breakdown structure of the thing we're looking at. We might group them in all sorts of ways, okay, which will help us to understand and manage maybe a large number of entities. And in this case, as I say, we've got a life cycle. We have draft, approved, managed, and closed or retired. And this is user definable. You can have more or less. You can call these things whatever you like. But this gives us a really good overview of what we've got. And at the top as well, we've got project settings. Okay. So we've got an instant picture, and this view is always available, as we will see. So we've got an instant overview, and we can navigate around the database using this as well. Okay, so let's move on to the core screen. So we've still got the overview on the left column. We've still got the leading particulars at the top. We've got links at the bottom. We've got notes in the middle. Okay. The information that's different for causes is that we can now allocate causes to a location on the in a vehicle or whatever it might be, or a building that we're analyzing, and also to the system breakdown structure. So, and that little blue and yellow sort of cogs that are really too small to see, that indicates there's a user definable model behind that. So you can load your system breakdown structure. You can load up a list of locations in your ship or submarine or plane or building or zones. We often break vehicles down into zones in order to do zonal analysis. So you can set up your zones in there as well. And this makes sense for causes, because a cause might be very specific to a particular area of the vehicle or a particular set of buildings, maybe a building where you've got flammable materials stored, a room there. So we've got causes that we can nail down to a specific location or part of the system. Okay. Whereas other entities, hazards and accidents, don't usually relate so neatly to a specific place. And again, so this is very powerful. We can set this up, and we can show where our causes are coming from, and incidentally where they're not, which might be a clue as maybe we've missed a trick here somewhere. So there's a quick look at the causal screen and the differences with that. And as I say, there's a bigger picture of, you can see that I think it's meant to be a gear or something, but it just indicates that there's a model there that says, yes, we've got a user definable breakdown here, a data dictionary, if you like, that we can relate to, and what project phase and what use are we putting this thing to when the cause arises. So we're getting towards the end of part one, and I just wanted to mention there's some resources in the chat. So first of all, if you'd like to subscribe for free emails, just click that link. Um, and then if you do, please check your junk email and put me on the safe sender list, because I'll be sending you discount offers and videos and educational stuff every week or so. So you'll be getting lots of resources coming through there. And that's, as I say, that's free, no commitment. And if you want to go and look at some courses, the Safety Artisan is on Thinkific, which is a lovely platform for running courses. It's a really nice, good user interface, nice experience. And in particular, on there, amongst the courses, I've got the Safety Engineering Academy. So, where I'm putting all the webinars, I think I've got half a dozen webinars on there now, adding another every month. So, all the webinar material plus extras is on there. So, copies of the slides, PDFs of the transcripts, and things like that. And also, there's a system safety community where people can get together and talk about system safety and ask questions and have them answered. And normally that's $45 a month. But if you use the 1 month free code, you will get, surprise, surprise, 1 month free. So you can try it out for free and see if you like it. Anyway, links to all of that are in the chat. Do help yourself and have a look, please. Let's move on. Okay, that's the end of part one. And that allows me to, excuse me, moisten my throat. And I think my leg is okay. If I stand up and start stretching my calves, don't be alarmed, okay? um, it's just a bit of cramp. So moving on then, let's talk about controls. Okay. So the control screen is slightly different. When I talk about controls, I'm talking about mitigations, things that might interrupt the accident sequence, things that might prevent the hazard occurring or mitigate its effects, okay, on either side of the bow tie diagram. So what's different about the control screen is we can allocate controls to an owner, and we can also track actions. So let's say we need to change the design to engineer in a control, an interlock or something, or we need some training material to be developed for the users or maintainers, whatever it might be. You can place an action on somebody. What's the target date? What's the status of the action? What's the target date? Um, what are we changing? Who's managing that? So that's a very powerful idea that yes, we need these controls to be implemented. Who is doing that? And there we go. Yeah. Um, Now I've got a little prompt in there: risk or control ownership. On many projects I've been on, people have tried to allocate ownership of risk to one person or group or organization or another. In my experience, that doesn't work very well, okay, because it's very difficult often to say, oh, somebody owns this risk or is responsible for this risk wholly. In a complex system, and if we didn't have a complex system, why would we need a sophisticated hazard log? But in a complex system, it's very difficult to divide up risk and allocate it neatly like that. But controls are another matter. We can allocate ownership of a specific control, and so that is a much better bet. So I would recommend allocating ownership of controls, but not of risk. Okay, that's too difficult in my experience. You just add up a lot of arguments really to achieve nothing. And then, so finally on our main screens, we've got our hazard screen. Okay. And what is different here on the hazard screen is we have no severity because the hazard has no severity. Let me just see. Are we going to, there we go. So accidents have a severity because somebody's got hurt or something's got damaged. Hazards do not. They're just an accident waiting to happen. So again, we have an initial status and a post-control status, other as in some probability. Um, as I said before, whether that is really valid for your project, you need to think about that. But it will have a probability. Okay, so that's useful for us to know. Then another one we've got here is the reference screen, and here similar sorts of data, but we can refer to a document, we can refer to maybe a section, specific section within a document, or a model. It may not be a document. And certainly Cassandra would allow us to hyperlink to artifacts. So if we had all our uh, safety evidence in a particular file location or server or whatever, we could set up some hyperlinks. And then if you, from the hazard log, you could click straight onto that and get to the evidence that you want to see. So yeah, a bit of overhead setting it up, but very powerful. So that's what we get on the reference screen. We might call it references, we might call it library or something else, but that's what it does. Okay, so I promised that we would talk about other functions. And we've got two screens of this because your typical database can do so much for us, so much more powerful than a spreadsheet. So first of all, if we've bought a commercial tool, usually they will allow us to set up user-defined data about the project. What fields do we want? What are the valid values for those drop-down fields, etc., etc. What's the work break? What's the product breakdown structure? What's the, what locations have we got? Whatever it might be. Okay, so we can tailor the tool to support the needs of our project. Okay, which is obviously very powerful and very useful. The other obvious thing that it gives us is security and access control, because we've got to log into the database to get in, and hopefully if we are cyber secure, nobody else can get in. So that secures our data against prying eyes. It secures privacy. Um, it means that we're not letting out you know, detailed and valuable information that we don't want to be spread around. And we can have different levels of access control. So if somebody needs to just have read access, that's fine. They can look at the data but not change it. Maybe somebody is allowed to enter data. Okay, often we give junior staff the job of looking after the hazard log, but there will be somebody more senior who is the administrator or super user, and they're usually the only people that can change settings. So we've got different levels of security and access control that is appropriate for the jobs that people are doing, which is great if you've got a team. Okay. So thirdly, we have version control. So the machine keeps track of the changes that have been made. So we can say, okay, this is the status of the data as it was entered at a particular time, or maybe after a meeting. Uh, if the appropriate authority says, yes, these changes to the database are authorized, and they go from being draft to approved on a particular date. And you can say this is version, X.X, whatever it might be. The other part of that is the logging of changes. So usually on these kind of databases, we can see it keeps a record of which logged on user made which changes and when. Okay, and usually the we will be, if we make a change, we'll often be asked automatically, why are you making this change? And of course, it doesn't force the tool isn't that clever, so it doesn't force people to give a meaningful answer. Although who knows, with AI, it could these days. But it does keep a track of who made what changes and when and why, which is very, very valuable when you're going back months or years later going, oh, why did we make that change? Why did that happen? Or who did that? How do we, what's going on here? That's very important. I've worked on on projects where you go in and discover that people have been making unauthorized changes, and instantly you're in a world of hurt because you don't know whether you can rely on any of the data in the hazard log anymore. You don't know what's good data, what's bad. It really is stuffed. Um, so all of these security features are very, very important. Okay, not necessarily because people have been malicious, but people make mistakes. They forget. They do stuff that seemed like a good idea at the time, and then there's a change of policy or whatever. Okay, things change. Another powerful feature, and we'll come on to the value of this in just a moment. We can track, perhaps, we can look at a hazard and say which, if we're recording probabilities, we could say, okay, which causes are the dominant causes of this hazard? Which causes are more likely than the other ones? Because it's rare that all causes are equal. Okay. And similarly, which hazards are contributing the most risk to which accidents? Okay, or the most probability. And again, it's rare for hazards to all be the same. Okay, some hazards are more equal than others, to misquote George Orwell. So it's great if we can track and see, well, what is the dominant core, or what are the dominant causes, what are the dominant hazards, so we can prioritize them and rank them and say, okay, we need to spend more time paying attention to these things. Uh, and a part and parcel of that is that that's one of the features of managing these many-to-many connections in the database. And in turn, these things allow us to do change and impact analysis. So let's imagine that we suddenly discover a particular control just doesn't work. We made a design change, or we put in a safety feature, or we were led to believe that people were doing maintenance on something or following a certain procedure. And then we discover that it's all nonsense, that it's not actually like that. It's not happening. So we can go and look at that control and go, right, this control doesn't work. What is it controlling? Which causes, which hazards? And instantly you can go, okay, I've lost a level of control on certain causes or certain hazards. And if this control, maybe for some things, is the only control we had on a certain, part of the map, couple of causes only have one control, and we now know that one control is useless. That's a priority that we need to address very quickly. Okay, so this change and impact analysis feature, allowing us to understand the impact of change or newly discovered information, is invaluable. Okay, and if we've done the links to all the evidence as well, if somebody asks the question, well, how do we know that this is safe? Or you get an audit and they say, okay, you say you've got these controls in place. Where's the evidence? You just go to the hazard log, click on the links, bang, there you go. It saves so much time and aggro. Um, I remember working on a very large fast jet program, and the UK Ministry of Defence had just lost a court action about aircraft noise. So inevitably, everybody got asked the question, where's the evidence that you've managed noise so that we got a robust position if we get sued again? And we knew we had this evidence, but it took us 3 days to find it. Okay. There was a team of us. And in between doing the day job, we were also looking for this evidence. As I said, it took us 3 days to find this piece of evidence. We knew it was there, but we could not find it. So, so when you do get something out of left field, you get a question or an inject that you've got to deal with, having a good robust setup like this can really save you enormous amounts of time and trouble. So very, very powerful features. Now, I think we've already covered change and impact analysis. Of course, what we can do if we suddenly discover that a cause is not managed or as well as we thought, or it's more prevalent and this cause is more likely than we thought, well, we can do the numbers if need be and see what the ripple effect is through the network of interrelationships between these causes and hazards and consequences. So you can do it manually, but it's very, very slow and painful. If you've got tool support, if you put all those linkages in, it gets a lot easier. Okay. So another thing that the tools give us is management overview. So usually these databases will generate reports which are user definable. So if management want to get an overview of what risks we're carrying at different levels, may be displayed on a risk matrix or whatever, however you want to do it, usually these tools will allow you to generate that report. You can do some reporting obviously in a spreadsheet. Or using Power BI, or stuff like that on raw data. But that requires, a skilled user to manipulate the data, or just more time to find the data, manipulate it, put it on display, and generate a report. Okay. Again, the tool usually will do that for you and comes with some presets, and then you can, if you want something special, usually you can set that up as well. Another big benefit of having a tool is that it can enforce standardization. So a good tool might have a spell checker in it, um, which might sound trivial. What's the importance of a spell checker? But if you've got the same word spelt two or three different ways in a database, if you start looking for the word spelt one way, you're not going to find all the instances. Okay. So if you've got non-standard data recording, usually in free text fields, or you've got bad spelling, or people are using different terms for the same thing, or whatever, it makes it much more difficult to search the database and find relevant information. So hopefully the tool will allow us to impose better standardization. And one of the ways that it does that is that you have drop down selection. So rather than having all free text fields, and free text can be abused, you have a drop down selection where only certain things are allowed. So, for example, if we've set up the 4 stages in the life cycle of a hazard, draft, approved, managed, retired, those are the only permissible selections, and that stops people putting in non-standard things and mucking up your metadata. Because, of course, if you've got drop downs, you can immediately search on what are my open hazards, what are my accidents in have I got any accidents in the red zone in the matrix? Because if you've got non-standard data in there, that gets a lot harder. So that standardization at both the macro and the micro level, standardization of a project. This is the standard system breakdown structure. This is the standard location breakdown. These are the standard um, phases in the project, and so on and so forth. Setting all that up forces standardization. And then at the micro level, if we're enforcing good reporting, good data recording, accurate spelling, consistent use of terminology. So we might have a reference to a glossary or a data dictionary. Okay, that can greatly improve the quality of our data, which makes it much more reliable and therefore much more useful. Okay, because you know if you've ever gone into a database and gone, oh, I've searched for a term, and go, but I've seen somebody else is using a different term for the same thing. So now I've got to search for that. And then I've got to search for spelling variations. Okay. Which, in these days of international projects and an international workforce, we're working as teams. where a lot of members of the team, whatever language that we're working in, let's say the project language is English, there will be a lot of people for whom English is not their first language. Okay, so we need to support people to get it right. So it's not about blaming people; it's about supporting people to get this right. And of course, with all these functions, this function here, these functions here, and the ones on page 1, can a spreadsheet actually do these things? And if it can, how can we do those things? And often the answer is you can sort of approximate it with a spreadsheet, but it's usually not very robust. Okay, you don't have the same level of control and security and checks and balances with a spreadsheet. Now, of course, there will be some spreadsheet gurus out there who can write fantastic macros to do some of this stuff. That's great. No problem with that. But of course, if your spreadsheet guru moves to another project and you're trying to unravel what's going on in your spreadsheet, then that can be tricky. So we'll talk about that in session 3. We'll do later. We'll talk about the what we can and can't do in a spreadsheet and some pitfalls to avoid. Usually, spoiler alert, usually we can do most things in a spreadsheet, but if the tool isn't supplying the discipline, we have to be very self-disciplined about using the spreadsheet as a hazard log or risk register. Okay, we have to have self-discipline, which means we have to strictly control who has access to the spreadsheet. Because if somebody is allowed in there who doesn't understand, there are business rules behind the spreadsheet, they can muck it up very, very quickly. Okay, and then final point, I think, and you heard this in the previous recorded session. The tool is just there to support the process. So here we've got a typical risk assessment process, and this is I created this diagram, but it's based on the ISO 31000 diagram, which you might recognize. So we've got risk assessment consisting of risk identification, risk analysis, and risk evaluation. We then treat the risk, okay, to reduce it. First of all, we've established the context. We've set up the project. We've set up the context of what does our system do? What is the system? What are we using it for? In what environment? Which we need all of that contextual data to do the analysis. And then we're going to be reviewing and monitoring. There's going to be a review cycle typically. And then also we've got to communicate and consult with stakeholders. And in fact, in some countries, I'm in Australia. In Australia, it is a legal requirement for us to communicate and consult and cooperate with different stakeholders or duty holders, as they're known. Okay. So we need a tool that's going to support us meeting our obligations, and the hazard log will help us to do that and record the leading data that we need to communicate with people that we need to present for monitoring and review. So when we design our hazard log, when we set up the project, we need to think about what we want to achieve and design the structure of the hazard log accordingly. And this is something that many people don't realize. They just think, oh yeah, hazard log, it has hazards and accidents and controls, and that's it, or whatever. You may need to include other data types in the hazard log and link them together in order to get the effect that you need on your project. Okay, so we've got to think about what do we want to do with the tool, what processes must it support, therefore what data do we need and what linkages do we need. And if we design the hazard log as a tracking system risk register accordingly, we will get much better results. Okay, and hopefully people will see the use of the tool, and if the tool is giving them benefits and help, they'll more likely to be careful about putting data in there and keeping it up to date. So hopefully we get a virtuous circle where things are getting better and better because we've designed the tool well and it meshes well with the processes and what we're trying to achieve on the project. So there we go, a bit of a hazard log evangelism there for you. Okay. So that's the double session on full function hazard logs. And we're just coming up to the hour, but we've still got some more time. I'm just going to stop sharing this and head back. Right. So we have an opportunity for some questions and answers, and I've got a couple of questions already. Thank you very much. So let me have a look. So I've got a question. By accident, are you referring to a postulated accident type or to actual accidents, even incidents that have actually happened? Okay, so thank you, James. So the answer is both. Okay, so we might have um, in our hazard analysis, we might have looked at historical data from a related system, maybe the system we're replacing or similar systems. So we might have real accident and incident data from the past, and also we might have estimated accident types and accidents, predicted accidents based on analysis. Okay, and so typically the most serious accidents tend to be what we call high consequence, low probability. Okay, so the most serious accidents are usually quite rare. Okay, because we've got things in place to stop them. So you've got to have a particular combination of, the holes in the Swiss cheese have all got to line up to get that accident. Okay, so we might be predicting something that has never happened. Okay, but in reality, um, I've heard people say, "Oh, that'll never happen on our project," and because we've done our homework, we've been able to say, "Well, it already has happened. You just don't know about it." Or we've had an incident that could have led to harm, but we got away with it. We were lucky. Okay, so that's your first question, James. Secondly, presumably allocating people to controls is mainly about actions are completed rather than them retaining ownership in perpetuity. Okay. Well, both actually, again. So first of all, we've got to somebody has got to do the thing. Um, they've got to implement the control. And then secondly, if we want that control to keep working, then somebody, usually it's monitored centrally, but we might have, let's say we might have people looking after technical publications or training. That's got to be kept up to date. So we might be allocating ownership to somebody through the life of the program, okay, as well as for setting it up in the first place. So great questions. Thank you, James. Right. Has anybody else got any more questions? Any more for any more, as we say. Now, I do believe if you are on uh, YouTube, Facebook, LinkedIn, or X, then you can submit comments to me. You can type in questions. So please go ahead. And those of you that are signed in directly to Restream via Eventbrite now, you might be able to talk to me. um, so has anybody got any more questions? So what I will do then, just as we are all right. So if working as a component supplier, you sometimes don't have system knowledge, so hard to connect to the accident. Yeah, excellent point. Um, really, if you're at a lower level in the supply chain, yeah, all you can do is analyze your thing in the context, whatever context you've been given by your customer, it will be difficult for you to see the big picture. And that's really the prime or whoever is responsible for delivering the overall system. They've really got to do their homework. They've got to do their systems engineering. They've got to do their system safety and work out the big picture and feed the component supplier the information they need. Yeah, excellent point. And it's one that in my day job, I work for a prime, and this is what I remind our people to say. Um, Typically, the prime can, or the prime, or the ultimate customer, the end user, can do the right hand side of the bow tie, but the suppliers at a lower level can usually only go up to the hazard level. Okay, they can't do anything else because they don't have visibility. Excuse me. Now I'm just gonna. Where are we? Ah, that's no good. I'm not gonna. What I'm gonna what I'm gonna briefly do is I'm just gonna share with you. If you were to head over to Safety Artisan on Thinkific, let me just share with you. Where's that gone? So if we were to head over to Thinkific, this is what you would see, and we've got a bunch of courses here, varying from the hazard identification. Let me just go through and show you. So we've got hazard identification, which is the smallest course, right through to, and here's the system safety engineering community, system safety assessment, which is all of the MIL standard 882 tasks, all 10 of them. And then we've got we've got principles of safe software and foundations of system safety and so on. And they all include different modules. You can see so here, for example, in foundations of system safety, we've got the first 3 tasks from the MIL standard 882. So I teach how to do your preliminary hazard identification and analysis and your system requirements hazard analysis. And then there's some bonus stuff there as well about putting all the different techniques together. Okay, so there's a bunch of resources. So if you click on the link and go and have a look, you can see what's included in the courses. And of course, the one I showed you has got to have a mistake in it, hasn't it? I'll get rid of that spare. You shouldn't be seeing that. But that's what you'll see. Oh, and there's the Safety Artisan website with all the latest blog articles, the free lessons, which there are several, and then the different kinds of lessons: software safety, Australian work health and safety, and also some stuff on cybersecurity. So, unless there are any more questions, oh, we have. Thank you. Any comment on ensuring consistency between controls that you have captured in the hazard log and formal requirements for the project? Yep, another great question. So, what we would do typically is, if we've identified the need for certain controls, those controls would become what we call derived safety requirements. Okay, they're called different things, but I'm used to them being called DSRs. So we've got a need for control. That becomes a requirement which we might allocate. If it's an engineering change to a subsystem, we might put that requirement in the specification for that subsystem, or we might have a requirement that to say, okay, we've got to have this content, these warnings and cautions in a technical publication, or we've got to have this training material, or we've got to have access control to keep people out of this dangerous area, or whatever it might be. So we would take those requirements and track them into some kind of entity, be it a design of a subsystem, or a document, or a piece of training with some artifact, whatever it might be. And yes, we do need to, when we're specifying those requirements, we do need to use requirements speak. So we do need to phrase the requirement as we would any other requirement. It's got to be, specific, measurable, achievable, all the rest of it. So we need to pass that requirement, PARSE, in a way that makes it unambiguous. And there are guides out there. So there's an INCOSE guide that I've used on how to produce good requirements. There are others. Okay. So, yeah. And of course, if we've got one control and it's the same control linked to many things, that will ensure consistency. Whereas if we've repeated the control or a very similar control many times, we'll lose it. So this is another reason for being rigorous about what we put in the database. So are we looking for a one-to-one linkage between the hazard log and requirements management tool? Ideally, yes. If we have in our requirements management tool or model, whatever it might be, if we've got, if it handles non-functional requirements as well as functional requirements, documentation and all the rest, great. If not, then we may need to link to different things, or maybe if we're doing an agile program, every control we raise a Jira ticket or whatever it might be to track the implementation and allocate it to somebody. Okay, so there's different ways of doing it, but yes, we do need that linkage from the control to how we're gonna do it. Or we could just do it if the hazard log supports that, as we've seen. You could just manage it in the hazard log with a series of review meetings and allocate work to people. Okay. Okay, you're very welcome. So, are there any other questions from anybody? Okay. So it just remains for me to say thanks very much for dialing in and all your inputs. And this webinar will be recorded, and it will be edited, and it will go on the Safety Academy site, so it will be downloadable and you can refer to it. And just wanted to say that next month, and I think it will be, let me just double check the date, next month on the 22nd of February, Thursday, the 22nd of February, I will be holding the next webinar, which will be about causal analysis, including fault tree analysis. So put that in your diary, please. I'll set up the next webinar in Eventbrite and on the Restream tool soon, and I'll be advertising that on LinkedIn and Facebook and elsewhere. So do keep an eye out for that, please. And if you found today useful, do please leave me a comment on the website, and I'll see you again in a month's time. So goodbye, everyone, and have a good day, night, wherever you are. Thanks very much for joining in. Okay.